Here we are provided with a vector valued function r, which is a function of the scalar parameter t. Then, using this information, we need to obtain the definite integral of the vector cross product between r with the second derivative of r with respect to t. So let's find it out. So here we will begin by first writing down the vector valued function r as a function of t. So it's given, it's equal to 5t squared I cap plus t times j cap minus t cubed times k cap. Let's label this as equation number 1. What we'll do, we'll take the derivative of r vector with respect to t. So that's equivalent to taking the derivative of the components of I cap, j cap and k cap with respect to t. So we'll have 10 times t, so that's the derivative of 5t squared times I cap. Here we will use the fact that I cap, j cap, k cap, these are constant vectors. So the derivative with respect to t, that will be equals to 0. So similarly, derivative of j cap with respect to t and derivative of k cap with respect to t, that will be equals to 0. Continuing, plus we have derivative of t with respect to t, so that's simply 1. So we have j cap minus derivative of t cubed will be 3t squared times k cap. So this is equation number 2. Now we'll use only 1 and 2 to obtain the value of this integral. The reason behind this is we are going to use the fact that, let's say we have derivative with respect to t of r vector crossed with dr over dt. Then if we use the product rule by assuming that r vector is our first function and first derivative of r with respect to t is the second vector function, then this is going to give us r vector crossed with second derivative of r with respect to t. So that means if we take the integral of vector r crossed with second derivative of vector r with respect to t, then this should give us dt. Then this will give us r vector crossed dr over dt plus the constant of integration c, which is going to be a vector. The reason behind this, we are taking the integration of a vector. So this is a vector on the left hand side. R cap crossed with the first derivative of r with respect to t is a vector. So that means in order for this particular equation to be valid, the second term, which is the constant of integration, must also be a vector. So that means our given problem, integration of vector r crossed with second derivative of r with respect to t over dt, so the integral value will be equals to r vector crossed with first derivative of r with respect to t plus the constant of integration. Of course, here we have a definite integral going from 1 to 2. So that means we'll compute the value of r vector crossed with dr over dt, the limiting at the end points going from 1 to 2. So let's obtain the value of r vector crossed with the first derivative of r with respect to t. For this, all we have to do is consider the 3 by 3 determinant, where in the first row we have I cap, j cap and k cap. Right. In the second row, we'll consider the components of vector r. These will become the entries of the second row. So for r vector, we have 5t squared. The component of j cap, that's t, and the component of k cap is negative t cubed. Right. Then in the third row, we'll have components of dr over dt. So that will, for that, we'll use equation number 2. So we have the entries as 10t, 1 and negative 3t squared. Right. So let's compute this 3 by 3 determinant. We will expand it about the first row. So we have I cap multiplied to t times negative 3t squared. So that will be negative 3t cubed minus 1 times negative t cubed. So this will become positive t cubed minus j cap multiplied to 5t squared minus 3t squared. So that's 15t raised to the power of 4 minus 10t times negative t cubed. So this will become positive 10t raised to the power of 4 plus k cap multiplied to, so we have 5t squared times 1. That's simply 5t squared minus 10t times t, and that will be 10t squared. Upon further simplification, we should get negative 2t cubed I cap plus 5t raised to the power of 4 j cap minus 5t squared k cap. So here we have r vector crossed with dr over dt. Now we will compute at the endpoint. So we will also compute the value of this vector at the endpoint. So let's do that. So this is going to give us negative 2 times, so we have t cubed, so that will be 2 cubed minus 1 cubed I cap plus 5 times t raised to the power of 4 will become 2 raised to the power of 4 minus 1 raised to the power of 4 j cap minus 5 times t squared, so that's 2 squared minus 1 squared multiplied to k cap. So this will give us negative 2 times 2 cubed will be 8, so we have 8 minus 1 I cap plus 5 times 16 minus 1 j cap minus 5 times 4 minus 1 k cap. So this is gonna give us, so we have negative 2 times 7, so that's 14, so we have negative 14 I cap plus 5 times 15, so that's 75 j cap minus 5 times 3, so that's 15 k cap. So this is the value of r vector crossed with dr over dt, which in other way we can say is the value of the integral r vector crossed with second derivative of r with respect to t integrated with respect to t. That means we multiply with dt.